So today what we're going to work on are minors and cofactors of a matrix. So let's talk about what a minor is. A minor of a matrix. So M sub ij of any entry A sub ij is the determinant of the matrix obtained by deleting the ith row and the jth column, sorry. All right, so when you have M, I'm just going to write this down here so I can see it bigger, of 1, 1, that means row 1, and that means column 1. Okay, so you're going to go to row 1 and column 1, and you're going to cross them out. You're going to just look at that 2 by 2 matrix and find the determinant. So you remember, you take these two multiplying together minus these two multiplied together. All right, so let's see here. So we want minor 1, 1. Okay, so minor 1, 1 means row 1, column 1. So you're going to go to row 1, column 1. This here, row 1 and column 1. You're going to cross them out, and you're just going to look at this 2 by 2 matrix. Okay, so minor 1, 1 is going to be negative 1 times 1 minus 0 times 2. So that's negative 1 minus 0, which is equal to negative 1. So minor 1, 1 is equal to negative 1. Okay, so now we're going to do minor 1, 2. Okay, so we're going to go to row 1, column 2. So row 1, cross that off, and column 2, cross that off. All right, so I'm looking at this matrix right in here. Okay, so minor 1, 2 is going to be 3 times 1 minus 4 times 2. So that's 3 minus 8, which is equal to negative 5. So minor 1, 2 is negative 5. All right, now we're going to do minor 1, 3. Okay, so minor 1, 3, we're going to go to row 1, column 3, cross them off, and we're just looking at this matrix here. So that's going to be 3 times 0 minus 4 times negative 1, which is 0 plus 4, which is equal to 4. So minor 1, 3 is equal to 4. Okay, so now what I would like you to do is find the other minor. So we did 1, 1, which is negative 1. 1, 2 is negative 5, and minor 1, 3 is equal to 4. So I want you to find the other ones. So put me on pause, find the other ones, and then come back and check your answer. Okay, so minor 1, 2, 1. So 2, 1. So that's row 2, column 1. I cross them off. So that's going to be 2 times 1 is 2 minus 0, because that's 0 times 1 is 0. So that's going to be equal to 2. All right, minor 2, 2. So row 2, column 2. So it's 0 times 1 is 0 minus 4 times 1, which is 4. So that's negative 4. And then minor 2, 3. So it's row 2, column 3. So it's 0 times 0 is 0, minus 4 times 2 is 8, so that's just negative 8. Okay, so now we want to do minor 3, 1. So it's row 3, column 1. So it's 4 times 2 is 4, minus negative 1 times 1 is negative 1, and that's equal to 5, because that's 4 plus 1. Now it's row 3, column 2. So 0 times 2 is 0, minus 3 times 1, which is negative 3. And then we need 3, 3, column 3, row 3. So that is going to be 0 times negative 1 is 0, minus 3 times 2, which is 6, so that's negative 6. Okay, so that's how you find your minors. Okay, so the next thing we're going to do is talk about how to find cofactors. So I'm just going to move everything up a little bit. Okay, so a cofactor, so C for cofactor, of I sub j is equal to negative 1 raised to the I plus j power times your minor. All right, so now when you get that exponent, I plus j, if that's an even number, then you're multiplying by positive 1, right? Because you're going to do negative 1 to an even exponent is going to be positive 1. And I plus j, if that comes out to be, this is a negative number, then you're actually multiplying by negative 1. Okay, so, and then you multiply that by its minor. So we're going to find all the cofactors for each entry in the matrix. So I want to find the cofactor for 1, 1. All right, so it's going to be negative 1 raised to the 1 plus 1 power, right? 1 plus 1 is 2, right? So I'm actually multiplying by positive 1 times my minor of 1, 1, which is this number here, negative 1. So I just get negative 1. So now I want to do my cofactor 1, 2. So it's going to be negative 1 raised to the third power. So that's just negative 1. So I'm multiplying by a negative. Times my minor of 1, 2, which is negative 5. So it's negative 1 times negative 5 is positive 5. And then the cofactor for 1, 3 is going to be negative 1 raised to the fourth power, which is going to be positive 1, times the minor of 4, which was right here. So negative 1 to the fourth power, that's positive 1 times 4 is just going to be 4. Okay, so let's do the next row. Cofactor 2, 1. So it's going to be, so 2 plus 1 is 3. So it's negative 1 to the third power, which is going to be, I'm going to multiply by a negative. And I need my minor 2, 1, which is 2. So I get negative 2. My cofactor 2, 2. So 2 plus 2 is 4. So I'm going to multiply by a positive 1. Times my minor of 2, 2, which is negative 4. So that's just negative 4. Cofactor 2, 3. So that's negative 1 to the fifth power is going to be negative times, and then 2, 3 of my minor is negative 8, so that's going to give me positive 8. All right, so I'm just going to move everything up a little bit. Okay, so cofactor 3, 1. So that's 3 plus 1 is 4, so that's going to be a positive. Times my cofactor of my minor of 3, 1, which is 5. So that's just still going to be 5. Cofactor 3, 2. So that's negative 1 to the fifth power. So it's going to be a negative times my minor of 3, 2, which is negative 3. So that's going to be positive 3. And then my cofactor 3, 3 is negative 1 to the sixth power, which is just going to be a positive, times my minor of 3, 3, which is negative 6. And that's just negative 6. So obviously there's a pattern. You see it comes out to be a positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay, so there's always that pattern starting off with positive first in the top left corner. Positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay, so let's flip it over and talk about determinants. Okay, so you can use cofactors to find the determinant. In a square matrix, 2 by 2 or greater. Now, we did 2 by 2s the other day, and then remember I said for anything larger than a 2 by 2, you can use your calculator. So now I'm going to show you how to find it by hand because we know how to find cofactors. So remember, the 2 by 2, let's say we have 1, 3, negative 4, 5. Remember, to find the 2 by 2, I made that a 5 there. We did 5 times 1 minus 4 times 3. And so that was 5 minus 12, which would be negative 7. Okay, so now how do we do, and you can use this method I'm going to show you now for this here too. Okay, but these are for 2 by 2 or greater. All right, so so we want to find the determinant using cofactors. All right, so the first thing you have to do is you have to find your minors. Now, in order to do this, the determinant is the sum, so we're going to add, of the entries in any row or column multiplied by their cofactor. So you have to pick a row or a column to work with. So for the first one, I'm going to work with, I'm going to start with minor 2, 1. So I'm gonna stick with row 2. So I'm gonna do minor 2, 1, minor 2, 2, and I'm gonna do minor 2, 3. So notice I kept the row constant, kept it at 2. All right, so let's find the minor for 2, 1. So remember, minor for 2, 1. So that's row 2, column 1. So that's going to be 4 times 0 is 0 minus negative 1 times 2, which is going to be negative 2. So that's 0 minus negative 2, which is equal to 2. Okay, so now we're going to find the cofactor, 2, 1. So it's 2 plus 1 is 3. So it's negative 1 to the third power, so it's going to be negative, times 2, which is negative 2. All right, so now we need minor 2, 2. So it's row 2, column 2. So that's going to be 0 times 0 is 0, minus 4 times 2, which is negative 8. Here. And now my cofactor of 2, 2. So 2 plus 2 is 4, so negative 1 to the fourth is going to be positive 1. Times negative 8 is going to be negative 8. Okay, so now we want to do minor 2, 3. So I need to do row 2, column 3. Row 2, column 3. Sorry, I can't erase the other one. So row 2, column 3 is going to be, so I crossed out the red here, sorry. So it's 0 times negative 1 is 0. And then 4 times 4 is 16. So it's 0 minus 16 is negative 16. And then my cofactor, of 2, 3 is going to be, so 2 plus 3 is 5. So it's negative 1 to the fifth power is going to be a negative times negative 16 is positive 16. Okay, so what I used here now to find my determinant, I'll call it the matrix A here. So I kept my constant row was 2. So I'm going to use row 2 here, which is 5, 1, negative 3. And then you're going to take each entry. So it's going to be 5 times its cofactor, which is negative 2. And you add it to, because it's the sum, 1 times its cofactor, which is negative 8, plus negative 3 times 16, its cofactor. Add them up and you get negative 66. All right, so let's try another one. So I'm just going to move everything up. Okay, so now we have to pick a row or column to be constant. So I'm going to pick a column to be constant. So I'm going to do minor 1, 3. I'm going to have my constant column be 3. Minor 1, 3, minor 2, 3, and minor 3, 3. Okay, so minor 1, 3. So that is row 1, column 3. So I cross that out. And then I have here 3 times 0 is 0. And 4 times negative 1 is negative 4. So 0 minus negative 4 is equal to 4. All right, so now I want my cofactor. So my cofactor 1, 3. So 1 plus 3 is 4. So negative 1 to the 4th power is going to be positive 1 times 4, which is equal to just 4. All right, now my minor 2, 3, sorry. So 2, 3. So it's row 2, column 3, cross them out. Okay, so I have here 0 times 0 is 0. 4 times 2 is 8. So it's 0 minus 8 is equal to negative 8. Okay, so my cofactor 2, 3. So 2 plus 3 is 5, so it's negative 1 to the 5th power is going to be negative 1, times negative 8, which is going to be positive 8. All right, so now I need my minor 3, 3. So that is row 3, column 3, cross them out. So I have here 0 times negative 1 is 0, and 3 times 2 is 6, so 0 minus 6 is negative 6 here. And now I need my cofactor. So my cofactor 3, 3, so 3 plus 3 is 6, that's going to be positive 1, times negative 6 is negative 6 here. Okay, so now to find my determinant, I'm going to call this B. Right, so my constant column was column 3, so it's 1, 2, 1. So it's going to be 1 times its cofactor, which is 4, plus 2 times its cofactor, which is 8, plus 1 times its cofactor, which is negative 6. So that's 4 plus 16 minus 6, and that comes out to be 14. Okay, so last couple things is this. If you have a 4 by 4 matrix, you can do all this, the minors and the cofactors, but obviously we get very tedious. Okay, so just use your calculator for that. Okay, so now let's talk about a triangular matrix. Sorry, I don't know why that red dot is there. Okay, so a triangular matrix is when all the zeros fall above or below the main diagonal. So this is an upper triangular matrix. So notice that on the main diagonal here, the numbers in the upper right triangle, I have those numbers here, and the bottom left triangle, those are my zeros. So this is an upper triangle matrix because my numbers are in the top right above the main diagonal. My lower triangular matrix, on the main diagonal, below the main diagonal, these are my numbers, and above would be my zeros. A diagonal matrix is when you have just the diagonal, and then below and above are all zeros. Now, to find the determinant of a triangular matrix, all you have to do is find the product of the main diagonal. So take a look at matrix number 1, so this guy here. To find the determinant, all you have to do is 4 times 7 times 2. And remember, this is if you have zeros in the corner and you have that main diagonal here, and you just multiply them. So we have 4 times 7 times 2, so that's 14 times 4, and that comes out to be 56. Okay, number 2. Same thing, I multiply the diagonal, so it's 4 times 9 times 1 is 36. And the same thing with the last one, just take the diagonals, number 3. 7 times negative 2 times negative 3, and we get positive 42 is my determinant. Okay, so that's it. I know today was a long video, but sometimes that happens. All right, so I'll see you in class tomorrow. Have a good night.